This is the Lusker PVD-75 sputtering evaporator. It's a compact unit that contains everything needed to complete deposition, including a vacuum chamber on this side and power supplies for the sputtering guns on this side. The actual chamber itself contains a substrate deck at the top where you put your glass substrates, securing them to it, and it rotates for consistency. As well, there are 3 sputtering guns down here which can be configured as DC type sources, for example for aluminum and metals, and for RF types for things like ceramics and dielectrics. Sputtering itself is a fairly slow technique compared to most. However, it is a very consistent technique. And at a certain known power and at a certain known gas pressure, you always get the same rate. In which case, it's pretty much a set and forget type process. The chamber itself consists of an upper deck which holds substrates onto which films are deposited. Substrates are held in by little metal clamps onto the backing plate. The backing plate then installs onto the shaft. During deposition, it rotates. And this ensures an even deposition since the actual guns are mounted in different positions around the actual chamber. Now the actual sputter guns themselves are located at the bottom. There's 3 of them, and they can all be DC or RF. In this particular configuration, I have a DC target back here with aluminum in it, and I have magnesium fluoride in the front, which is operating off an RF supply. Shutters on top of each one allow you to start and stop depositions. Generally speaking, the shutter is kept closed. The actual power is ramped up from 0 to the final power, and then the shutter is opened to start the deposition. This is called a ramp, and it's used to reduce thermal stresses within the actual materials themselves. Let's take a look at one of the guns right now. Okay, we're going to take a look at gun number 1, which is connected to a radio frequency supply. In this particular case, it's used for magnesium fluoride, but it can be used for any dielectric type material. So the shutter is now open, and I'm going to take the shield off so you can see what's inside. 3 Allen key screws secure it. So this is the outer shield. And if I remove it, you can see the actual target material in the center. Let's remove that as well. Hold down ring and the actual material. Now, this particular material, magnesium fluoride, is bonded onto a copper backing plate. The copper backing plate is then in contact with this copper plate. Now this one's part of the sputter gun itself. It's water cooled, which means water is brought up into the gun and back down to cool the backing plate. So the material itself, the magnesium fluoride, never really gets hot during deposition. In fact, it barely gets warm. The other thing about this copper plate is it's electrically connected to the radio frequency generator. So this is how energy is brought into the actual target itself. And finally, there's a rather large magnet located inside this gun. The large magnet is necessary to keep the discharge going. There's going to be an electrical discharge inside the actual chamber, And in order to maintain that discharge at low pressures, you need a large magnetic field to do it. So this is a typical sputter gun. All three look essentially the same. I'll reassemble this gun now and we can start a deposition. Obviously, it's important when installing this ring not to crack the target. Apply gentle pressure, and now it's mounted. Now the ring itself, the actual shield, as you see here, goes over the whole setup. And it's very important that the shield never touch the actual inner parts of the gun, or you'll create an electrical short and it'll never work. Generally speaking, this shows up on the power supplies as being 0 volts if you short it out. Usually what I do is I take a meter, if it's a whatever type of target it is, from underneath I'll take a multimeter, a DMM, and I'll check the resistance between the inner terminals, the one that's part of the gun, and the outer terminal that's part of the shield, to make sure that they're not shorted. This is especially true with something like the aluminum target on the back over here. It's a very easy thing to check with a multimeter, and it always pays off. The system contains a single DC source and an RF source, both of which are controlled through the touch screens on the front of the unit. It's rarely necessary to actually use the controls on the power supplies themselves. Now I've reinstalled the target and I've installed glass substrates into the upper mounting deck, so let's do a basic deposition of aluminum. Deposition begins by evacuating the chamber of air. Turn on the roughing pump through the vacuum screen. Then turn on the turbo backing pump. At which point, the chamber is now being rough pumped. We continue rough pumping this chamber until a pressure of 100 torr has been achieved. When we're down to 100 torr, as seen on the wide range gauge for the chamber, we can then activate the turbo pump to take it down the rest of the way. So we've achieved our 100 torr, and now it'll let us activate the turbo pump. The turbo pump itself will ramp very slowly from 0% speed all the way up to its final speed that we've selected. The speed itself of the turbo pump, as indicated here, is actually relative to the vacuum levels. So as we pull a higher and higher vacuum inside the chamber, there's less resistance on the blades of the pump, and the pump will spin faster until it comes to its final value. It's now a matter of waiting for the chamber to evacuate fully. The vacuum level is now below 2 times 10 to the minus 4, and it's time to start our deposition. We start first using the substrate menu to start the motor rotating. Press motor rotate to turn on that button. Touch the speed. In this case we'll enter 25%. And the motor is now rotating at 25% of its maximum speed. Next, let's go to the gas screen. We start by turning on gas injection and then selecting an MFC. What we'll select is mass flow controller number 1, which is argon, and we'll put that into control mode. It's now the active gas. Touch set point and select the pressure you want, in this case 10 millitorr. And we'll notice here the pressure is bouncing up and down quite a bit. If it doesn't stabilize in a few seconds, it means that the PID parameters are incorrect. Press Auto Tune, and that will automatically set the P, the I, and the D parameters for you. Notice now how the pressure stabilizes on our exact set point of 10.0 millitorr. Next, we go to the deposit menu. And for this example, we'll be depositing aluminum. So power supply number 2 is selected. Make sure we select the source switch. Put in the actual set point you want. This is the final value of power that we want to deposit at. So I'll touch this, and I'm going to set it for 200 watts. Next, select the ramp that you want. This is how fast it gets to that final power. And it's 5. Now 5 is a fairly fast value. However, this is an aluminum target. It's completely pure aluminum. It's unbonded, and so we can get away with that. And finally, set the soak. And in this case, I'm going to set it for 100 seconds for this demonstration, although that's a very short soak. So the power will go from 0 to 200 watts at 5 watts per second. It'll then open the shutter and soak for 100 seconds. This is the actual time of the deposit. When the deposit is done, it'll close the shutter and ramp down back to 0 at 5 watts per second. In order to start this off, we push auto dep and the process will start. Notice the power slowly ramping up on the target. This ensures that we don't put too much power to the target at once, which would cause large thermal gradients between the top and the bottom of the target. Remembering that the bottom of the target is actually on a water-cooled backing plate. We've achieved our value of 200 watts, which is our set point. Soak now begins with the shutter open. So we're now depositing aluminum onto those glass substrates. When the soak interval is complete, the shutter will automatically close and the power will ramp down, once again in this case, at 5 watts per second from its current value of 200 watts down to 0 watts. This allows the target to cool slowly. When we've reached 0 watts, the power supply shuts off and we're ready to do another layer if necessary. And here we see the DC target performing a deposition. The power is now being ramped up 200 watts at a rate of 5 watts per second. When the power of 200 watts is reached, the shutter will open automatically and the deposition is now being performed. This is the soak period and it'll continue for 100 seconds, the way it's programmed currently. In reality, depositions are usually a lot longer than 100 seconds. With the soak period now complete and the deposition being done, the shutter will now be closed automatically and the power will ramp down. Next, we'll deposit a layer of dielectric, in this case magnesium fluoride. This requires the use of the radio frequency supply. We'll select power supply number 1 in this case. Once again, we'll select the source to connect the power supply to the actual gun itself. We'll select our set point of 250 watts. The ramp is already set for 2 watts per second. That is a very slow ramp, but necessary for materials like this. These materials, for example magnesium fluoride, most oxides as well, can easily crack when you heat them up due to thermal stresses. So by ramping them up and down very slowly to their final powers, you can preserve them. The soak Once again, for this example, we'll set it for 100 seconds. And now we're ready to go. However, there is a trick. RF targets do not like to light. Now, there's several methods that can be used to light RF targets, including raising and lowering the pressure. So literally turning them on, setting the pressure higher, and then setting the pressure lower. The other way to do it is to open and close the shutter. And finally, the other way to do it is to light it from a running DC target. And since we have a working DC target on this machine, we'll do that. So before starting the actual deposit, we'll go back to our aluminum. We'll set the set point for only 10 watts. We'll leave the shutter closed, and we'll turn on the power supply. So now I have a glowing DC target inside the machine. The actual shutter is on top of it and closed, so I'm not depositing anything. But because the shutter doesn't fit very tight, I'm blowing electrons and ionized gas into the chamber, and that's what's going to light our RF target. So I'm going to leave the DC target running. I'm going to switch to the RF target. I'm going to push auto dep to start it off. And then to get it to start, I'm going to open the shutter and then close it again. And the target just lit. So at this point, the actual radio frequency target, the magnesium fluoride on the front, is lit and it's glowing. I no longer need this DC supply, and I can simply turn it off. It really wouldn't matter whether I left it running or not, I suppose. And now this target can complete its deposition. It'll ramp up to 250 watts at a slow rate of 2 watts per second, and then it'll perform the soak for 100 seconds. After which it'll ramp down again at 2 watts per second until 0 watts is reached. So the only trick with using an RF target is ensuring that it lights. In order to deposit using the RF target, the DC target is first started at a low power level. Notice how the glow looks underneath the shutter. Electrons and ionized gas molecules are being blown into the chamber, and it's those that are going to ignite the RF target. I start the auto deposit on the RF target, and then open and close the shutter of the RF target until it ignites. At this point, the ramp continues for the RF target, and we no longer need the DC target at all, so I'll simply turn it off. And now the deposition will continue with the RF target, slowly ramping up, opening the shutter, soaking, closing the shutter, and then continuing. It's also important to note when lighting an RF target that if it doesn't light immediately, stop the deposition. Do not continue. If it doesn't light, the problem might be that it may ignite later at full power. This would cause a huge thermal gradient and undoubtedly crack the target. So if you're going to light an RF target using a DC target, you have to do it at very low power levels, and you have to ensure that the target actually lights. If it doesn't, turn off and start again. When the depositions are complete, and they might well consist of several layers, the chamber can be vented to atmosphere before removing the substrates. Begin by ensuring the power supplies are both turned off. From the substrate menu, turn off the motor rotation. From the gas menu, shut down the gas injection. And finally, from the vacuum menu, in order, turn off the turbo pump, turn off the turbo backing valve, and finally the roughing pump. The turbo pump will now slowly spin down until it stops. Now, because we're already below 50%, we can vent the turbo pump directly. If it isn't below 50%, you have to wait until it actually naturally slows down to that value. Push the turbo vent button, and that releases dry nitrogen into the chamber, which slows the turbo pump and fills the chamber with gas. That's the chamber pressure right there, and we can see it rising. The chamber can be opened when the vac symbol, which is currently green, indicating the chamber is under vacuum, turns gray. It's now gray, indicating the chamber is no longer at vacuum. Turn off the vent, and the chamber can be opened. Our deposition is now complete, and the substrates can be removed from the holder.